Okay, doing a Zoom recording as well as recording on a higher quality camcorder. Zoom only records at fairly low resolution. Camcorder's much higher resolution. So we might get a clearer picture from the camcorder. The disadvantage of camcorders, it takes forever to upload from anywhere other than the college. And it takes a while there because, of course, have an extremely fast connection there. Okay, well, just a little background. A little more background. I'm down in a cave. Actually, I'm in my basement. Pretty much the same thing. Walkout basement. Fortunately, it's spring now, and the nights aren't so cold, so it isn't as cold in here, but I do have an extra layer on. In the middle of the winter, it got as low as in the high 30s, not too bad. Okay, well, you don't really need to know all that, but here's what we have now. Okay, I had a brilliant idea, very relevant to our course, and you'll see why. But I have several jars here. Okay, well, it's going to rain. We had a heavy rain about a week ago. So I set these jars outside where the rain would fall into them. And then I measured how much water was in each jar by weighing them to the nearest gram. Okay, and gram is really a unit of weight, but we don't have to worry about that. And there are ratios and proportionalities involved with this process. And there is a modeling process that would allow us to estimate very accurately the relative diameters of these jars. So, but from the weights of the water, we can do some very simple things that you're going to be able to do within 2 weeks of starting the course, and gain a whole lot of insight into the modeling process. Now, of course, if I want to measure the diameters of the jars, I get a micrometer and do that, except that, well, there's some problems with that. So obviously, nobody's all that interested in what the diameters of these jars are. But the process, the mathematical modeling of the process is the same as the mathematical modeling of much more complicated processes that you don't want to be messing with when you're first learning to do any kind of modeling with functions, proportionalities, etc. So to simplify things, we look at this very simple situation. Now, I've sketched circles up here. I'd like to claim that I sketched these freehand, and I'm really not too bad at doing freehand circles, but I can't get them that good. Okay, so I've done these three. I'm going to do this one so you see how it's done. Take a piece of chalk and start drawing a circle. Back here and whoops, twisted the chalk. Oh, something's gone wrong there. Okay, got a little bit of a lump there because the chalk twisted a different way and I wasn't able to get the point quite right. Worked pretty well on these three, but there's obviously kind of a lump there. Okay, now it should be obvious if you look at what happened that the circle I drew there is a little bigger than the jar. So the rain is falling. Well, but still, let's just pretend these are the accurate circles. So rain falls from whatever direction. It falls equally well into any one of the jars, but there's more area for the rain to fall into in this jar than there is in this jar. And how many of these would it take to make this? It's a little hard to visualize that. We could actually, I wouldn't want to do it because it takes a while to build one of these boards, but I could actually take a jigsaw and cut out these circles and weigh them and figure out how many times bigger this one is than this one. Of course, we can use what we know about the area of the circle, and we could measure the radius of this circle and the radius, or the diameter of this circle and the diameter of this circle, figure out the areas, divide the diameter of this circle or the area of this circle by the area of this circle, and see how much more area there is here than there is here. Now, it's actually unnecessary to do that. We just take the two diameters and square the ratio of the diameters for reasons that we hope to make apparent. They really should be from the prerequisite courses, but I seriously doubt it from experience. Okay, so why is that related to how much water is in each of these jars after the rain? Well, if this one has 3 times the area of this one, it should hold 3 times as much water. Okay. If this one has twice the area of this one, it should hold twice as much water. Well, I've got the weights and everything. So there are things that we can do to understand how collecting rain in these jars gives us information about their relative diameters. So if I know the diameter of any one of these jars, I could then determine the diameter of the others. And then I could check all my data for consistency to make sure that it really does work out the way it's supposed to. Now, you don't know exactly how we're going to do that, but it's not that difficult. Now, one problem, of course, is we can't use these circles to calculate as a basis for calculating the relative areas in which the rain falls because the circles are too big. Each circle is, well, let me just, I'll use this last one. It appears to me that the chalk mark is at least in error by this much on each side and top and bottom. In other words, the actual dimensions of the jar are better indicated by the marks that I've made here. And also, it's very difficult to know exactly what this ratio would be because we really need the inside diameter of the jars, and it's real hard to get inside the jar when you have it up against the board like this. Okay, so our pictures on the board are not totally accurate, but we could say, okay, well, let's see, let's see if I get I should be able to draw a pretty good circle here since I've got the outside circle as a template. Yeah, not too bad, but not too good either. Okay, maybe this is the inner measure of the circle. Maybe this would give us a pretty good idea of what the inner diameter is. If we go over to this circle, I have to, the chalk mark is whatever distance it is outside the circle, no matter which circle. So when I draw the inner circle for this jar, I'm taking out a relatively bigger chunk of the area of the outside circle to get to the inside circle than here. Because, this strip that I'm taking out here has the same width here as it does here. Well, we can prove that I'm taking out a bigger chunk of the small area, of the area of the big circle here than I did here. Okay, like here, I'm maybe taking out 30% of the area of the big circle. Here, maybe only 10%. Now, those are just guesses. I don't really know what the percent would be because I haven't measured these things. I could make a pretty good estimate, but we don't need to worry about that. Okay, so I can hold this jar up to this picture, and let's get it aligned with the camera to see if I've got a reasonable representation of the inside area by this. Well, I could then use those circles to make estimates. Not actually going to do that. Actually, we might have some problems related to that, but I want you to understand the question. Okay, the question is, if we wanted to do this by making these circles and represent the inner diameter, we would need to know how the inner diameter is related to the outer diameter, or the diameter of the chalk line. Okay. Now, I'll also say there were two more containers, but they were a couple of my wife's favorite bowls. And I took enough risk taking them outside. I set them in a very secure place in hope that we didn't have a really bad hailstorm. But I can't bring those bowls down here. This ledge is a little bit narrow, and I'm not going to risk my life by bringing my wife's good bowls down here and setting them here. You get the idea. Okay, so the bowls, maybe had a diameter of about like this, then about like this. You're going to get data, and I'm going to ask you to do some things with that data. And I'm not sure exactly how I'm going to arrange the data. There's several ways. But for example, I could give you the weights I got for the water in each of the vessels, okay? And ask you to calculate, do some simple calculations and determine the relative areas of the circles from the weights. It's really very easy to do that. So that's what you're going to be looking at. So this is going to be kind of your first modeling exercise in the course. It's simpler than the modeling exercises I've used in the past because it's pretty easy to understand what's going on. Okay, so you have that to look forward to. And just trying to see how long this video is, and it's hard to read that screen. Oh, there it is. Okay. So you have about a 12-minute video to suffer through, so you'll understand what's going on. Okay. Let's